Now, let's use the guidelines from the last videos on these examples. I am going to write down the guidelines for you again here. So number one, the first thing you should try when it comes to finding a limit is substitution. All right, number one, substitution. Try to use the numbers right away. Maybe by plugging it in, it can give you the limit values. So if this works, then great. But if it doesn't work, then you may need to try this number two. Try to rearrange your function. So number two right here, rearrangement. Right. Try to move things around some terms, and maybe in the end you get some cancellation out of that. All right. Now, if this number two doesn't work, then you may need to try this number three, which is to try different paths. All right, paths. We are talking about straight line paths, parabola, quadratic exponential. You need to try those. All right. If this doesn't work again, then you need to try this number four, the last resort, other techniques. Alright, let's try these on some of the examples here. So let's take a look at this number one. The first thing I'm going to need you to do is to change a typo on this y approach to 0. It's supposed to be y approaching 1. Alright, change this to 1. Okay, so let's try to find the limit values of this function. So the first method that I'm going to take is the substitution. Number one, substitution right here. So I'm going to plug in x equal to 0 and y equal to 1 into this function, and maybe I can get the limit values right away. So let's try that. X equal to 0 right here is going to be 0 minus xy, which is going to be 0 times 1 plus 3. Alright, divided by the denominator here we have x squared, which is 0 squared, times y, which is 1, plus 5y, which is 1. And what do we have here? We have this 3 for numerator, and we have this 5 for the denominator. So in the end, we have this value of 3/5 or 3 over 5 for this first example. And as you can see here, for this one, the substitution works right away. So we can stop right here, and we can answer that the limit for this multivariable function is 3/5. Okay, let's move to number two. Right here we have this x approach 0 and y approaches 0, and we have a fraction again. And once again, the first thing we should try is to use the substitution. So I'm going to do that. So here x squared is going to be 0 squared minus xy, which is 0 times 0. And here I have this square root of 0 minus square root of 0. And in the end, I have this, all right, 0 for the numerator and 0 for denominator. And as you know, what we have right here is 0 divided by 0, and this is indeterminate form. Indeterminate, which means that we cannot tell anything about this value, no conclusion. And it also means that we have to try something else. So what you see right here is that substitution fails. Number one fails. So I'm going to try number two, which is the rearrangement. By looking at this fraction, I see some pattern right here. So let's take a look at this. I have this x squared minus xy divided by square root of x minus square root of y. What I see right here is sort of like a minus b, front minus back. When I see something like this, I think of conjugation. You know, a minus b. I'm going to multiply this with a plus b. So I'm going to do this times with a I'm sorry, let's change this to a plus b right here. A plus b, and we are supposed to have the same thing for the numerator right here, a plus b. Okay, so let's put that in. A is square root of x plus square root of y, that is b. And up here, same thing, square root of x plus square root of y. So there you go, we use this conjugation to try to rearrange things in this function. Conjugation. All right. So let's try what are we going to get here. So for the numerator, I am going to take some common factor out of this. So for this one, I'm going to take x out, and in the end, I have this x minus y. And the conjugation factor right here, I have this square root of x plus square root of y, and that is the numerator. Now let's take a look at the denominator. As we can see here, a minus b times a plus b equal to a squared minus b squared. Sometimes you call it front minus back times front plus back. You get front square minus back square. But you can use this formula right away. So here what we have is a squared, which is x, all right, minus b squared. B is square root of y, so b squared is y. So in the end, at this point, we see something nice, which is the cancellation of this x minus y and x minus y. In the end, we have this x square root of x plus square root of y. So let's make a conclusion right here. In the end, it's going to be equal to limit of when x approach 0 and y approaching 0. And here we have this new term. Let's use it. After the cancellation, by using the conjugation, we have this x square root of x plus square root of y. And at this point, we are going to apply substitution, right? Plug these numbers in. Number 1, right? So what do I get here? 0 goes in, square root of 0 plus square root of 0. And in the end, we have this 0. By the way, what we have right here is determinate. This is not the same as 0 divided by 0. So you can answer right away. The answer for this example is equal to 0. And that is the limit value. Right? So that's it. For this one, substitution fails and we try the rearrangement. Now let's take a look at this next example. So here we have this a limit again, and we have a fraction, and here we have this x approach 0 and y approaches 0. And let's try the substitution quickly. So I'm going to try it right here. 0 is going to go in, and I'm going to get 0 minus 0 divided by 0 plus 0. And in the end, I have this 0 divided by 0, and as you know, this is indeterminate. Alright, and by the look of this, it doesn't seem like I can rearrange things to get cancellation, because when you have a denominator like this, x squared plus y squared, it's kind of hard to get rid of that. So I would assume that 2 is going to fail here, because I can't think of any way to get rid of some terms right here. So 1 and 2 fails. And this example is going to be about number 3, which is to try different paths. So we are going to try this one. Number 3, for the guidelines, different paths. So we are going to try this. Try to approach this this limit from using a straight line direction. All right, and we are talking about this this point 0, 0. So it's going to be at the origin, and we are going to try to approach this point by using straight line. All right. The first thing we are going to try here is this. All of these lines, and as you know, all of these lines can be represented by this one expression, y equal to kx. All right, we have this expression. So what we are going to do here is to plug this into the function, to substitute this into the function. Okay, so let's take a look here. We have this limit of x approaches 0 and y approaches 0, and here we have x squared minus y squared divided by x squared plus y squared. So we are going to work on this. y is going to be equal to kx, and it's going to go into here and here. Alright, let's work on this. Limit of x approaches 0 and y approaches 0. The front term still the same, x squared, and here minus y squared, but we know that y equal to kx, so this is going to be kx squared. Alright, same with the denominator, we have this x squared plus y squared, and y equal to kx, and of course we have this square at the end. So let's take a look here. What do we have? Here we are going to have limit of x goes to 0. Oh, I need to save some space, so let me change this. Okay, this is going to be equal to limit when x approaches 0 and y approaches 0. And here at the top, let me work it out here. I'm going to take the common terms, that's going to be x squared. And here I have 1 minus k squared left in the parentheses. And here at the bottom, I have this x squared. And I'm going to have this 1 plus k squared left in there. So let's bring that to here. So in the end, I have this common factors of x squared at the front, 1 minus k squared, divided by x squared, 1 plus k squared. Alright, and of course you see something nice right here, that we can cancel this out. X squared go away. So we have this in the end, limit of x moves to 0 and y approaches 0, and of 1 minus k squared divided by 1 plus k squared. Alright. At this point, I want you to take a look at this. This is about the limit when x approaches 0 and y approaches 0. And as you can see here, what we have right here, there is no x or y in there, which means that we can just get rid of this limit. And in the end, the limit that we want is going to be equal to 1 minus k squared. Alright, minus k squared divided by 1 plus k squared. And that is the answer we have right here. 1 plus, So, I want you to pay attention to this. This is very important. What we have right here, 1 minus k squared divided by 1 plus k squared. What this is the limit value of this problem. This is limit values. So make a note right here, this is limit value. And as you can see, in this expression, this limit value depends on k. As you can see here, it has k inside, so limit value here depends on k. Depends on k. So what does this mean? It means that the limit value is going to be different at different k. Okay, make a note right here, very important. Limit value is will be different at different k, different value of k. For example, if k, I'm sorry about the space right here, but let me write it down. If k is equal to 0, what is the limit value? So let's try to put 0 into here. Right, 0 and 0, then the limit value is going to be obviously 1. But if k is set to be 1, then 1 goes in here and 1 goes there, and we get limit equal to 0. Alright, as you can see here, at different values of k, limit values are going to be different. So what does this mean? It means that limit will be different along different direction, along different directions. Alright, so the key word is right here. Different directions, limit will be different. And as you know, each direction is represented by different k. Looking at this. And these lines has different k. And which means that along each line, the limit are going to be different, right? And if you can remember the definition of the limit that I mentioned in the last video, limit exists only when all sublimits are equal. All of them, all of these. No matter how you approach this point, this origin, all the limits have to be equal for the limit to exist. But as you can see here, in this case, they are different. So we have this condition right here. The limits are different at different k, which means that in this case, the limit does not exist. Okay, so make a big note right here in this example, limit DNE does not exist for this example. And the reason for that is because the values that you get depends on the k, and k changes along each direction. So due to this. All right. Now let's take a look at another one. So in this example right here, we have this 0 and 0 for x and y. And let's use the substitution first. So as you can see here, 0 goes in, we have 0. And for the denominator, we have 0 as well. Also indeterminate. So you can try to rearrange things, but from the look of this, xy divided by x squared plus y squared, I don't think I can cancel anything out. So I'm going to try number 3 again, right? Different paths. So paths, and in this case, straight line again. All right, same thing, straight lines, and they are going to be represented by this expression, once again, y equal to kx. Okay, so we are going to substitute this into our limit. So we are going to have this limit of x moves to 0, y moves to 0 of xy divided by x squared plus y squared. And this is going to go in, y equal to kx. So we have this x the same here, y equal to kx. Alright, down here we have this x squared, same here, plus y squared, y equal to kx, and has to be squared. So what do we have in the end? We have this k of x squared, and down here we have a common factor of x squared. And the front term I have left here is 1 plus k squared. Alright, and of course we can cancel these x squared. And in the end we have this k divided by 1 plus k squared. Alright, so we can, in the end this is equal to limit of k divided by 1 plus k squared when x approaches 0 and y approaches 0. And as you can see here, in this expression, we don't have x or y in there, so we can just get rid of this. So in the end, the limit value is going to be equal to k divided by 1 plus k squared. Once again, this is the limit of this example, and this limit we see right here, k divided by 1 plus k squared, it depends on the values of k. This limit depends on value of k, which means that sublimits will be different along different directions. Alright, why? Because along different directions they are different case. So, alright, so from this we can make a conclusion for this example that the limit does not exist. Once again, the limit exists only when all sublimits are equal, right? Limit dne does not exist in this example because it changes with the values of k. Now, let's take a look at the next one. Well, this one we have this xy squared divided by x squared plus y to the fourth. So let's try to use the substitution first. So let's put zeros in. So here we are going to get 0 at the numerator and divided by 0 plus 0, definitely indeterminate. And from the look of this, everything is square and only plus sign. I don't think I can get rid of any terms here. So I'm going to try to use the number 3 different paths. 3 paths right here. And I'm going to start with the straight line. Okay, so let's try that out. And straight line, we are talking about y equal to k of x. And we are going to use this in this limit. So let's work that out. Limit of x approaches 0 and y approaches 0. And we have this xy squared divided by x squared plus y to the fourth. So here we have same thing. Well, a lot of writing. X approaches 0, y approaches 0. And then up here, x still the same, but y is going to be equal to kx. Y equal to kx square. Alright, we have square at the end, and divided by x squared plus y to the fourth. So let's put y equal to kx in. So kx to the power of 4. Alright, so what do we have here? Let me work a little bit further on this. So we have this x cubed k divided by, here I have common factor of x squared. Here inside I have this 1 plus k squared x squared. And here I can cancel x squared with this 3. Alright, so in the end I have this x k divided by 1 plus k squared x squared. Alright, let's put the limit back into this. Okay, so I'm going to put it right here to save some space. So we have this equal sign right here, and the limit comes back to this point. Alright, x goes to 0 and y goes to 0. As you can see here, we still have x left in this expression, so we cannot leave this out. We have to bring the limit back. So we have this x and x. Since this limit has x approaches 0, so we are going to put that in. So 0 gonna go in here and 0 gonna go in here. So what do we get here? In the end, we have this equal to 0 divided by 1 plus 0, and this is equal to 0. Alright? Now, what does this mean? It means that along all straight lines, directions, it's going to come out to be 0 in every direction. So we are talking about this. Alright? All of them, all of these straight lines. And they were represented by this y equal to kx, and in the end, they all come out to be equal to 0. Which means that they are all the same. All sublimits. And make parentheses right here, straight line. Are the same. And they are equal to 0 in this case. Alright, so straight line, good. But as you know, it's not just about the straight line. Sometimes we have to try parabola or quadratic or exponential too. So let's try some other different ways to approach this same point. we have tried the straight line. Let's try parabola. Okay, so number 3 again. Alright, we are going to try different paths, but here we are going to try parabola. Alright, for a parabola you can use y equal to kx squared, or the other one is x equal to ky squared. That depends on the situation. One is the parabola upside and upward and downward, and the other one is the one on the sides. Alright, so why don't I use this one for this example? This one is parabola on the side. Alright, okay, so I'm going to use this one. I'm going to plug this into the limit that I have. So I have this limit, well, a lot of writing again, xy squared divided by x squared plus y to the 4th when x approaches 0 and y approaches 0. So we are going to plug this into the limit values. So let me work out on this. So x still the same, alright, and y here, oh sorry, x is going to be equal to ky squared. I'm sorry, because I used the parabola on the sides. X is going to be equal to ky squared. Alright, sorry about that. This is equal to ky squared times y squared. Alright, divided by x squared. In this case, x equal to ky squared plus y to the 4th. Now let's work on this one. Up here I have ky to the 4th. Alright, and down here I have this common factor of, oh, by the way, I'm sorry, there is one mistake right here. This is supposed to be ky squared in here. So down here at the denominator I have this common factor of y to the 4th, and what I have left in the parentheses at the front term is k squared, alright, plus 1. Okay, this looks good now. Now looking at this, I can cancel this. Alright, and at this point I need to bring back the limit to this expression. Okay, limit of x approaches 0 and y approaches 0 of k divided by k squared plus 1. And as you can see here, in this expression, no x or y in there at all, so I can get rid of this. Doesn't matter now. So in the end, for this limit, it's going to be equal to k divided by k squared plus 1. Now let's take a look at the meaning of this. This means that the limit value is going to depend on k. Alright, this limit value depends on k. On k, which means that along different directions, along different k, limits are going to be different. Alright, so let's take a look at this. What we just tried right here is to use the parabolas on the side to approach its origin. We use this. And along these lines, they have different k's. Alright, so we try these to approach the origin. And since the limit depends on the values of k, it means that the limits are different on different paths. The limits values, the sublimits values, sublimit values are different along different paths. Alright, which means that different paths means different k. Therefore, the limit does not exist here because it requires the limit, all the sublimits to be the same in order for the limit to exist. And since they are different here, the limit does not exist for this example. And that is the answer. Limit D, and E for this example, and we found it on the parabola paths. It was fine with the straight line, right? They are all equal to 0. Everything is fine for straight line. But when we try the parabola on the side, and then this turns up, it depends on k, which means that along different of this approach, they have different values of limits. So limit does not exist for this kind of approach. Okay, so to conclude on this, sometimes using the straight lines are not enough. You have to try different ways when it comes to approaching that limit. And in this case, we were successful with the parabolas on the side. Now, this summary is about the same thing as what we did, so I'm not going to spend time on that. I am going to skip to this squeeze technique. Sometimes we call this sandwich. Alright, sandwich technique. And this is a technique that you can use to find the limits when all the other guidelines failed. So this is the number 4. Alright, so let's try to use this kind of technique on this example. Once again, let's take a look here. We have a fraction of x and y, and x approaches 0 and y approaches 0. So let's try the substitution at the beginning. So here we have this 0 at the top and then 0 at the denominator, definitely indeterminate. Now, let's assume that we have tried everything, the rearrangement, the different paths. You try straight lines, you try parabolas, you try exponential, and they turned out to be inconclusive. So we don't know what to do with this, so we are going to rely on this new technique, sandwich. So let's take a look how it's done. Alright, now let's focus on the function we have right here, 3x squared times y divided by x squared plus y squared. But I'm going to start this problem a little bit different. I'm going to start with this term, which is quite similar to what we had, but not exactly the same. X squared divided by x squared plus y squared. Let's focus on this one. When you look at this fraction, one thing we know for sure is that this fraction cannot be larger than 1. Do you agree with me? Why? Because the denominator is always larger than the numerator, right? So, and they have to be positive. So in the end, we have this extra y. They have to be less than 1. And once again, you notice all these squares, which means that this fraction has to be positive always. So we have this relation between the left-hand side and the right-hand side. I'm sorry. The fraction we see right here has to be positive, but in the meantime, it has to be less than 1. Okay. Now, the next thing I'm going to do is to multiply these inequalities with 3. I'm going to multiply 3 to all the way through. So I'm going to do this. Times 3, and times 3. What's going to happen here? So here I'm going to get the same 0 on the left-hand side, and here in the middle, I'm going to get 3x squared divided by x squared plus y squared. And on the right-hand side, I am going to get 3. Now, this starts to look like what we have in the example, but not yet. The next thing I'm going to do is to multiply y to all the way through. Alright? But when you multiply y into an equality, there's going to be it's going to be a little bit tricky, because if y is negative, then the directions of this inequality is going to switch. Alright, so let's talk about this with 2 cases. The first case is when y is greater than or equal to 0, when y is positive. Y positive. When y is positive, if you multiply y in, it's not going to change the sign at all. So in the end, it's going to come out to be 0, same thing. In the middle, it becomes 3x squared y divided by x squared plus y squared. And on the right hand side, what do we have? We have this 3y. Okay, 3y. And now, the other case when y is less than or equal to 0, or in other words, y is negative or 0, then the sign of this inequality is going to be backward, right? So here, instead of having less than or equal to, this is going to be greater than or equal to. And in the middle is going to be the same, 3x squared y divided by x squared plus y squared. And same thing here, the sign go backward. And here we have 3y. Alright, now focus on this. This is exactly the same as the one in the example. And the next thing we are going to do is to apply the limit throughout these two inequalities. So limit is going to go in here, limit go in here, and limit goes in here. Same here, limit, limit, and limit. Now let's take a look at the result here. So here we are going to have the limit of x goes to 0 and y goes to 0 of 0 less than the limit of x goes to 0, y goes to 0 of 3x squared y divided by x squared plus y squared less than or equal to the limit of x goes to 0 and y goes to 0 of 3y. And that is the first case. Let's take a look at the next one. Limit of x goes to 0 and y goes to 0 of 0 larger than or equal to limit of x goes to 0 and y goes to 0, 3x squared y divided by x squared plus y squared greater than limit of x goes to 0, y goes to 0 of 3y. Now let's take a look, let's work these out. Limit of 0 when x goes to 0 and y goes to 0, of course we are going to get 0 out of that. Okay, so we have 0 right here. Less than or equal to the middle, we leave it the way it was. So limit x goes to 0 and y goes to 0, 3x squared y divided by x squared plus y squared less than or equal to. We are looking at this term when y goes to 0. Y equal to 0, it means that this side on this right hand side is going to be equal to 0. Alright, so on the other side we have the same thing. Here this one is going to be 0, and in the middle we leave it the way it was. We have this same greater than or equal to the limit of x goes to 0 and y goes to 0 and 3x squared y divided by x squared plus y squared greater than or equal to. Now this one, 3y when y goes to 0, of course we have 0. So let's make a conclusion here. We want to know the value of this term when x and y goes to 0, and this is what we want, right? This is what we want. And they turn out to be in between 0 and 0. Of course, this is going to have to be equal to 0 because this term is got squeezed in by values of 0 on the left hand side and the 0 on the right hand side. And that is the case for y is positive. When y is negative, the same thing happened. This same value, the limit that we want, got squeezed in by two values of 0, one on the left hand side and the other on the right hand side. So in the middle it has to be equal to 0. So the conclusion of this is that the answer for this example is going to be equal to 0 as the final answer.